All right, so let's take a look at this example of inverse functions. We're going to use this example here. Let's figure out what the inverse function of 1 over x plus 2. So this is the, if you recall, this is the reciprocal function shifted up 2. So the parent function, all right, parent function, or the base function, or however you think about it, is like this type. And that's 1 over x. Y equals 1 over x. Okay, but we're on this one, which is 1 over x plus 2. So it's related to that. It's an upshift of 2. Now, when you're determining what an inverse function is, you first change your f of x notation to y equals notation. Then what we do is, okay, we switch x and y. So it becomes x equals 1 divided by y plus 2. So now we're looking at a totally different function. Not f, but a new function. When the x and y switch, and it's of course going to be the inverse function. Solving for y, we subtract 2. And now, kind of a simple way to get y by itself is take the reciprocal of both sides. And here we are with the value of y. Just to kind of finish it out, a lot of times at this stage you'll write it using f inverse notation, or f of x notation. And here's our inverse function. We can prove that those are indeed inverses of each other by composing. And we look to see, is it equal to x? So f of, so we can put a question mark there if we want. F of the inverse, so the inverse is this formula. So I'm going to put that formula in place of f inverse. Now, in place of the input on the function, I'm going to put this formula, 1 over x minus 2. So this becomes 1 divided by x minus 2 plus 2. One divided by something is another way to say reciprocal. So the reciprocal of 1 over x minus 2 is x minus 2. Negative 2 plus 2, they cancel out. X equals x. They are inverses. Now we should also, I could put dotted line here to keep it in one space, one page. We should also check to see that, okay, what about the other way? What if we do f composed with the inverse? Whoops, we did that one. Let me put on a new piece of paper here. So what about f inverse and f of x here? What's that equal to? Well, hopefully it's equal to x. If it's equal to x, then we have proven that algebraically that yes, these are inverse functions. So we say f inverse f of x is this formula. F inverse, well, f inverse is 1 over x minus 2. So it's 1 over x plus 2 minus 2. 2 minus 2, of course, those cancel out, so it's 1 divided by 1 over x. And the reciprocal of that is x. So yes, they are inverse functions. Okay, now another thing we can look at is domain and range. So we'll use the same functions we've been working with for this example. Now the domain and the range on these two basically switch. So the domain for the function f is all real numbers, but x can't be 0. Now that should match the range of the inverse. So the range of the inverse is, well, it can be any real value but y will not be 0. Let's take a look at the domain of the inverse. The domain of the inverse is, it can be all real numbers, but x cannot be 2. Which means that the range of the original function is all real numbers, but y cannot be 2. So they essentially trade places. And next video we'll take a look at what the graphs of these look like.